necessarily the surface shall not be closed. If the surface were closed, you have no boundary. Think about that. Okay? So necessarily the surface is not closed. Think about sphere. There's no boundary in terms of curve. It's empty. You know what I mean? If you have a sphere, there's no boundary. Everywhere you go, there's no boundary. So you need to be not closed surface. And then this is an edge of a surface. Think about that. It needs to be open to have edges in 1, 2, 3, okay, so that's a C altogether. And the theorem says you do so by curl operation of surfacing. And they want you to reduce this to this, and hoping this is more doable case, which is really hard to say, but that's what they want you to do anyway. All right, so let's do this in detail. You're going to have to reproduce again. So what is C? C is a curve intersection of the plane with cylinder. Well, we can do that all the time. Here's a cylinder. You have a plane not going to the origin. You see the x, y, z plus equals 1. One thing is very clear, the origin is not on it. See, if we're 0, 0, you're not going to 1. That means 0. So one thing you know is 0, 0, not on it. Okay? It's not important, but it's good to know it. So when you do the picture of this, you really have a triangle right here. Basically, you're going to intersecting all the axes away from the origin. And so I don't want to draw a triangle, so otherwise my picture will be very bad. Anyway, it's going to be like this. Okay? If you're intersecting, this is where the plane is. This is the intersection. This is the C is. So surface is right here. It's a flat ellipse tilted in an angle of the plane, right? So the S is right here. The C is right here. Okay? So we're looking at the surface as bounded by this ellipse tilted in space. Okay? And then obviously, so let's reduce. Let's say what's the surface? The surface. The key is identifying the surface completely without. The surface is taken from the plane first, which means z must be 1 minus x minus 1. However, that's not the surface. This is the whole plane until you do the domain over which the surface is defined. So the d you need to identify, obviously. Since everything's given from the book, we'll give you nice numbers, which is 3 squared. So basically the domain is a disk of radius 3. And once again, this is defined by a function. A surface is defined by a function. Okay? So that's the preparation. However, to do it, you actually have to compute this first before you apply whatever we've already done here. So there are a couple more steps to go before you see the answer. So let me compute the curl operation first, which means, yeah, I would suggest that you use the full formula right away. So there's no point to do the cross multiplication, especially for functions. So let's, what is that? F is x squared zi plus xy squared j plus z squared. Okay, all right, this is P, this is Q, this is R. Can you read for me? Anybody has a card, flash card? Do you have one? Well, anybody has, just read to me. I know it begins with R something, RZ. So that's how you can, rather than going through determinant, I would do it if I were forced to do it.
Ry minus qz.
Okay. Ry minus qz.
Ez minus rx. PZ minus RX.
PZ
Yeah.
minus RX.
QX minus PY.
Yeah, that's the only thing I
That's
remember.
yeah.
Because this comes from the two-dimensional case where we have a difference. So, and it's rather hard to remember, especially sign change. Technically speaking, this should be minus of. Remember by the determinant, as soon as they both switch the order, so it becomes positive. If you do determinant, this is a minus of Rx minus PC. So anyway, now I prefer just do this because the functions. Py, no, R1, 0. QZ, 0. And PZ, which is x squared, minus Rx, 0. QX is y squared minus PY, 0. So considerably simplified. Okay? 0I plus x squared j plus y squared k. That's a curl. Alright? And then name this is your new P, new Q, new R. Remember, don't mess us with the P or R original F. This is a new vector field. When you apply this formula, you have to use new ones. Alright, so let me continue.